Hi class, today's video is called Prime Factorizations, and the purpose is to show you how to use a factor tree to find a prime factorization. So for today, you're going to need your glossary and also some scrap paper and a pencil. The prime factorization that you found using the product puzzle was fine. You know, the product puzzle is a fun method and it's like kind of a challenge, but it's certainly not efficient. If you need to find a prime factorization for a given number, you're not going to build a product puzzle and go through all of the different factorizations until you can find the prime factorization. So I'm going to show you a method today that's going to shorten that. There's a lot of information in today's video, so please pause it, replay it, watch it as many times as you need, because I'm going to be moving really quickly. We're going to start with some definitions. First, you'll need the definition for prime factorization. There you have it there. Pause it, copy it down, and come back when you're ready for the next one. Next, we have two definitions that go on your E page, expanded form and exponential form. Again, pause the video, copy the definitions, and come back when you're ready. Finally, we have the definition for standard form. One last time, pause the video, copy the definition, and come back when you're ready. Okay, now that you have all the definitions copied down, let's talk about how do you find a prime factorization without a product puzzle? And the answer is factor trees. So to create a factor tree, you're going to write down your number that you're trying to find the prime factorization for, and then two little lines coming down from it. And you're going to think, what can I multiply? What two factors can I multiply to get this product? In my example, I have used 3 times 9. Then you're going to take each of those factors and break them down even farther. So 3 is already prime. I'm going to leave 3 as it is. And 9 can be broken down into 3 times 3. 3 is a prime number, so this is as far as we can go in a prime factorization, and that right there is the prime factorization for the number 27. So just review, in standard form, that number is 27. In exponential form, it's 3 to the third. And in expanded form, it's 3 times 3 times 3. Okay, so a few important things to remember when you are talking about, or when you're doing prime factorizations. The first important thing is not to use 1 in your prime factorization. So here's an example of what that might look like if I did try to use 1. I have the prime factor, I have the number 27 and a factor tree for it. I said 3 times 9 is 27, and 3 is 1 times 3, and 9 is 3 times 3. And then 1 is 1 times 1, and 3 is 3 times 1, and 3 is 3 times 1, and 3 is 3 times 1. And I could go on and on and on and not really get anywhere. 1 does not go into a prime factorization, because we can say times 1, times 1, times 1, times 1, times 1 to infinity, and it doesn't really change the value of the number. Okay, the second important thing to remember is that there are many trees in some cases that can still lead to the same one answer. So here's an example for that. I have factor trees here for the number 36. You can see in this first one, I split 36 into the factor pair 2 times 18. In the second one, I used 3 times 12. Down below, I have 2 more, 4 times 9 and 6 times 6. All 4 of these factor trees are correct, but they all start out differently. They all end, however, with the same 4 digits, maybe just in a different order. So that's why it's important when you write your final answer to either put your answer in exponential form or write your factors in order from smallest to largest. So no matter which factor tree you would have created for the number 36, you should have 2 times 2 times 3 times 3. And one final thing to remember is, what do you do with prime numbers? And here's the answer for that. I have here a prime number. I tried to make a factor tree of it, 23. The only factors of 23 are 1 and 23. So you can't actually make a factor tree for 23. If you're asked on a problem or in class what the factor tree for a prime number would look like, you can just answer, there is no factor tree for that number because it's prime. Now for a little bit of practice. I'd like you to make a factor tree for the number 40. Then write the prime factorization in expanded form and also exponential form. Keep in mind what we talked about and make sure that your factors are in order from least to greatest. Hit pause, make the factor tree, and come back and check your answer. Okay, you should be done with your factor tree, and here is one possible factor tree for the number 40. Even if your factor tree looks different, you should have ended up with 2 times 2 times 2 times 5 as your expanded form of the prime factorization, and 2 to the third times 5 as your exponential form.